An auto-transformer compensator is a type of reduced voltage starter used for induction motors. It is designed to reduce the high inrush current experienced when an induction motor is started directly online. When an induction motor starts, it draws a current that can be several times higher than its normal running current. This high inrush current can cause voltage dips in the power supply system, potentially affecting other equipment connected to the same system. An auto-transformer compensator addresses this issue by applying a reduced voltage to the motor during starting, thereby limiting the inrush current. Once the motor reaches a certain speed, the full rated voltage is applied. The working principle of an auto-transformer compensator involves using an auto-transformer to step down the supply voltage to a lower level, which is then applied to the motor terminals. An auto-transformer is a single-winding transformer that uses a portion of its winding as both the primary and secondary winding. This configuration provides a voltage reduction while maintaining a direct electrical connection between the input and output. The auto-transformer typically has multiple taps, allowing for different voltage reduction levels, often expressed as percentages such as 50%, 65%, or 80% of the line voltage. During the starting sequence, the auto-transformer is connected between the power supply and the motor. The operator selects a tap that provides the desired voltage reduction. For example, if the supply voltage is 480 volts and a 65% tap is selected, the voltage applied to the motor will be 0.65 multiplied by 480, which equals 312 volts. Applying this reduced voltage to the motor lowers the starting current. The current drawn from the supply line is also reduced by the square of the tap voltage ratio. If the tap is set to 65%, the line current is reduced to 0.65 squared, which equals 0.4225 or 42.25% of what it would be during a full voltage start. Once the motor accelerates to a predetermined speed, typically around 70% to 80% of its rated speed, the auto-transformer is switched out of the circuit. The motor is then connected directly to the full line voltage. This transition can be achieved using timers, current sensors, or speed sensors. The switching process usually involves a multi-step sequence to ensure a smooth transfer and minimize any voltage transients. This is often done with a closed transition, meaning the motor is not disconnected from the power source during the transition. A closed transition can be achieved using resistors or reactors that are temporarily inserted into the circuit during the switching process. The purpose of these resistors or reactors is to limit the current surge that can occur when the motor is switched from the reduced voltage tap to the full voltage. Firstly, consider the selection of the appropriate voltage tap on the auto-transformer. The tap selection depends on the motor's load characteristics and the allowable starting current. A lower voltage tap results in a lower starting current but also reduces the motor's starting torque. If the load requires a high starting torque, a higher voltage tap may be necessary. Secondly, think about the design of the switching mechanism. The switching mechanism must be reliable and capable of handling the motor's starting current. It also needs to provide a smooth transition between the reduced voltage and full voltage operation. Thirdly, there are the protective devices incorporated into the auto-transformer compensator system. These devices include overload relays, short-circuit protection, and undervoltage protection. These devices are designed to protect the motor and the auto-transformer from damage due to faults or abnormal operating conditions. Firstly, the starting current is reduced, which leads to reduced voltage dips. Auto-transformer compensators effectively reduce the high inrush current during motor starting, minimizing voltage dips in the power supply system. This helps to maintain stable voltage levels for other equipment connected to the same system. Secondly, the starting torque control can be adjusted. By selecting the appropriate voltage tap on the auto-transformer, the starting torque can be adjusted to match the load requirements. This allows for optimized motor starting performance. Thirdly, there is less stress on the motor. Reduced voltage starting minimizes the mechanical and thermal stress on the motor, extending its lifespan. Firstly, there is the cost. Auto-transformer compensators are generally more expensive than other types of reduced voltage starters, such as resistor or reactor starters. Secondly, the size and weight should be considered. Auto transformer compensators can be relatively large and heavy, requiring more space for installation. Thirdly, there is the heat generation. Auto transformers can generate heat, especially during long starting periods, which may require additional cooling measures. Auto transformer compensators are commonly used in applications where reduced voltage starting is required to minimize voltage dips and protect the power supply system. Some common applications include large pumps, fans, compressors, and conveyors. These applications typically involve motors with high starting torques and high inertia loads. An auto transformer compensator provides a controlled and efficient method for starting induction motors, minimizing the impact on the electrical grid and extending the life of the motor. The selection and application of an auto transformer compensator depend on a variety of factors, including the motor size, load characteristics, and the requirements of the electrical system. By understanding the principles of operation and the key considerations, engineers and technicians can effectively utilize auto transformer compensators to achieve reliable and efficient motor starting. When selecting an auto transformer compensator, it is essential to consider the motor's nameplate data, including the horsepower or kilowatt rating, voltage, full load current, and locked rotor current. The locked rotor current, also known as the inrush current, is the current the motor draws when it is initially energized and the rotor is not yet turning. This current can be several times higher than the full load current. The auto transformer compensator should be sized to handle the motor's locked rotor current without overheating or experiencing excessive voltage drops. The load characteristics play a significant role in selecting the appropriate voltage tap on the auto transformer. Loads with high starting torques, such as pumps and compressors, may require a higher voltage tap to provide sufficient torque to overcome the initial inertia. Loads with lower starting torques, such as fans and blowers, may be started with a lower voltage tap to minimize the inrush current. The voltage drop in the power supply system should also be considered. If the power supply system is weak or has a high impedance, the voltage drop during motor starting can be significant. In such cases, a lower voltage tap may be necessary to limit the inrush current and maintain acceptable voltage levels for other equipment. Firstly, there is the impedance of the power source. The impedance of the power source affects the voltage drop during motor starting. A lower impedance source can better handle the inrush current without significant voltage drops. Secondly, there is the cable size and length. The size and length of the cables connecting the auto transformer compensator to the motor and the power supply can affect the voltage drop. Larger cables with shorter lengths minimize voltage drops. Thirdly, there are the other loads connected to the same circuit. The presence of other loads on the same circuit can exacerbate voltage dips during motor starting. Auto transformer compensators typically include several protective devices to protect the motor and the auto transformer from damage. Overload relays protect the motor from overheating due to excessive current draw. These relays strip the circuit breaker or starter if the motor current exceeds a predetermined threshold for a certain period. Short circuit protection devices, such as fuses or circuit breakers, protect the motor and the auto transformer from damage due to short circuits. These devices interrupt the current flow very quickly in the event of a short circuit. Undervoltage protection devices protect the motor from damage due to low voltage conditions. These devices trip the circuit breaker or starter if the voltage drops below a certain level. Some auto transformer compensators include phase failure protection, which protects the motor from damage due to a loss of one or more phases of the power supply. This type of protection is particularly important for three-phase motors. It should be inspected regularly for signs of damage or wear. The connections should be checked to ensure they are tight and free of corrosion. The protective devices, such as overload relays and fuses, should be tested periodically to ensure they are functioning correctly. The auto transformer itself should be inspected for signs of overheating, such as discolored insulation or a burning smell. Auto transformer compensators are typically installed in a motor control center or a separate enclosure. The installation should comply with all applicable electrical codes and standards. The auto transformer compensator should be properly grounded to ensure safety and prevent electrical shock hazards. The wiring connection should be made according to the manufacturer's instructions and should be properly labeled. It is important to ensure that the autotransformer compensator is adequately ventilated to prevent overheating. The enclosure should be kept clean and free of dust and debris. Autotransformer compensators offer several advantages over other types of reduced voltage starters. Firstly, they provide a higher starting torque per amp of line current compared to resistor or reactor starters. This is because the autotransformer provides a true voltage reduction, while resistor and reactor starters introduce impedance into the circuit, which can reduce the voltage and current. Secondly, they offer a wider range of voltage taps, allowing for more precise control of the starting torque and current. This makes them suitable for a variety of applications with different load requirement. Thirdly, they can be used with motors of any size, while some other types of reduced voltage starters are limited to smaller motors. However, autotransformer compensators also have some disadvantages. Firstly, they are generally more expensive than other types of reduced voltage starters. Secondly, they can be relatively large and heavy, requiring more space for installation. Thirdly, they can generate heat, especially during long starting periods, which may require additional cooling measures. Several other types of reduced voltage starters are available, each with its own advantages and disadvantages. Resistor starters use resistors in series with the motor windings to reduce the voltage during starting. They are relatively simple and inexpensive, but they provide a lower starting torque per amp of line current compared to autotransformer compensators. Reactor starters use reactors or inductors in series with the motor windings to reduce the voltage during starting. They are similar to resistor starters in terms of performance and cost. Y-delta starters connect the motor windings in a Y configuration during starting and then switch to a delta configuration once the motor reaches a certain speed. This type of starter is relatively inexpensive and provides a good starting torque, but it is only suitable for motors that are designed for Y-delta starting. Part winding starters energize only a portion of the motor windings during starting and then energize the remaining windings once the motor reaches a certain speed. This type of starter is relatively inexpensive, but it provides a lower starting torque and is only suitable for motors that are designed for part winding starting. Solid-state starters use electronic components such as silicon-controlled rectifiers or insulated gate bipolar transistors to control the voltage applied to the motor during starting. They offer precise control of the starting torque and current and can provide smooth, stepless acceleration. However, they are generally more expensive than other types of reduced voltage starters. The selection of the appropriate type of reduced voltage starter depends on a variety of factors, including the motor size, load characteristics, the requirements of the electrical system, and the budget. The autotransformer compensator is a versatile and effective option for applications requiring reduced voltage starting, particularly where high starting torque and precise control are needed. Always consult with a qualified electrical engineer or technician to ensure that the autotransformer compensator is properly selected, installed, and maintained. They can assess the specific requirements of the application and recommend the most appropriate solution. Furthermore, local electrical codes and standards should be adhered to. These codes and standards provide guidelines for the safe and reliable installation and operation of electrical equipment, including autotransformer compensators. Compliance with these codes and standards ensures that the installation meets minimum safety requirements and is less likely to cause problems in the future. Proper documentation of the autotransformer compensator system is crucial for maintenance and troubleshooting purposes. This documentation should include wiring diagrams, component specifications, and operating instructions. Accurate and up-to-date documentation can save time and effort when diagnosing and repairing problems. Proper training for personnel who operate and maintain the autotransformer compensator system is essential. Trained personnel are more likely to operate the system safely and efficiently and are better equipped to identify and resolve problems. Training should cover the principles of operation, maintenance procedures, and troubleshooting techniques. Finally, record keeping is an important aspect of maintaining an autotransformer compensator system. Keeping records of inspections, maintenance activities, and repairs can help to identify trends and prevent future problems. These records can also be useful for warranty claims and insurance purposes. By following these best practices, you can ensure that the auto transformer compensator system operates reliably and efficiently for many years.